guys. This is Shawn Willsey, Geology professor, and we are here in Iceland with NatureEye to do a live stream flight over these young lava fields. So we're going to go ahead and take off. I'm at the controls. Thanks for joining us this morning. And here we go. So there we are looking, I believe we're looking, what direction is that, Johan, I'm looking at first? That's looking north.
Oh, you're looking pretty much southeast right now.
Okay, that's southeast, he says. Great. So yeah, we're here, and I'm in my office in Idaho at the college here, and I'm controlling this drone, thanks to NatureEye, that's located in Iceland. And so we're able to actually use this great technology, and we can see that February 8th lava field just below us there that's still degassing, the heat still rising out from that. And the hill to our left here, that's Stora Stogafeld. And just to kind of give you a little bit more perspective here, we'll kind of swing the camera around towards the power plant in the Blue Lagoon. There's Sýlingarfeld, another hill. And there's the power plant and the western edge of that February 8th lava field. And with our drone flight here, so we're taking off from a little bit different place than we did previously. What I thought we'd do, what I'm mostly interested in, is getting out over to the vents and looking at what those vents look like from the February 8th eruption. And we'll also be over the December 18th eruption site as well. Remember that these two eruptive events overlapped quite a bit spatially. So what we can do here is move up over the hill and then maybe get like a nice bird's eye view to start with. And then we'll descend off the hill and move down a bit down over the vents to the east here. So this is just a fantastic opportunity to do this. And you can do this too. This NatureEye technology is available to anyone. If you go to their website, of course, if you use the code ShawnFly, I believe it's my name, and then FLY, you can get a $10 discount. And it's not just good for here in Iceland, but they have a variety of locations. There's places in Africa, safari type locations, waterfalls, Machu Picchu, just all sorts of different places. You can fly a drone on your own, take pictures as you go, and just have a wonderful experience. So I just appreciate the good folks at NatureEye for making this all possible. It certainly has brought another level to what I'm doing with geology here and my YouTube channel. It's just fantastic. So we're kind of cresting over the summit of Stora Stogafeld. And then I thought we'd kind of look around a little bit here. You can see there's a little thin blanket of snow on the ground. And then those black lava fields just stand out. I mean, it's kind of crazy. You'd think that this was a black and white video, but this is all in color. It's just the landscape right now has these kind of contrasting light and dark areas. We're going to continue to go up a little bit higher here, and then we'll pan around a little bit with the camera. Just doing all this with my keyboard. We'll swing around this way and maybe bring the camera down a little bit. So now we're looking to the north at the lava field. Now you can see where this tongue of lava kind of swept around the west side of Stora Stogafeld. Let's move the camera up a little bit here. There we go. So that's looking towards the north, towards Reykjavik, towards the capital area. And let's just kind of keep swinging around to the north and then to the west. So there's that other branch of the February 8th flow. So you can see that it's degassing as well. And now we're looking more or less kind of northwest and then to the west here. So there's more of the February 8th flow. There's that leading edge of the flow out there. And then we can even use the zoom feature here. So we can zoom in a little bit, move the camera up, and get a nice view of you can see the berm here. So that was the protective wall that was built around the Blue Lagoon and the power plant. And then this lava flow, they've established the roadway that comes through here. You might even see a car rolling through there. And this lava field never really tested this barrier much. It kind of found a little drainage in the topography and flowed to the west before the whole event subsided. So let's go back to just regular zoom. There, of course, is the power plant. Now we're swinging around towards the south a bit here. And let's get the camera just right. And now we're looking at this just big expansive lava field, which again is the two combined lava fields that we have from the December eruption and from the February 8th eruption as well. And so let's go. Let's keep swinging around this way. And then let's head down a little bit. So let me swing the camera over to this area and we'll start moving forward now. So now we're heading to the west. You guys should be able to see all the same controls I'm using here. So the simple WADS, that controls the drone sort of where it's swinging around. And then I've got arrow buttons forwards, backwards, and such. So we're going to head down now and drop down in elevation. We need to stay under 120 meters or so. And let's go over here. We need to make sure we have good line of sight with the home base there where Johan is. Now let's go check out some of these vents. I'm interested to see how some of these vents look from the February 8th eruption. And let's drop down a little bit too high. And again, these lava fields can take literally years, sometimes decades, to completely cool and crystallize. Now, the surface is probably, cool enough to walk across, although I definitely don't recommend that. But the temperature underneath can still be quite hot for some period of time. Let the camera kind of catch up a little bit there. It's a little pixelated on that side. Pretty fantastic. So now let's kind of get down a little bit lower and see what we can see here. Great flow textures here in the lava. So we're looking at some of these very smooth, somewhat ropey surfaces in the flow. And it looks like we had one of the vents over here you can still see is degassing a little bit. Swing around a little bit here. I'm obviously not as smooth as Johan with the controls, but still able to move this thing around a little bit.
Oh yeah, Shawn, I just want to tell you, you're in a kind of blind spot.
Oh,
if you see that home pot.
Blue.
So just take it up a bit and
yeah, I got a little too low there. So it's not responding to my up. Do you want to take over real quick and get it? There we go. Now it's going. Okay, thank you. Yeah, let me look at the map a little bit here. So head a little bit more to the south.
Yeah, you might want to head just southwest.
Okay, great.
So you have line of sight.
Yeah, I couldn't tell on the map where I was with respect to the hill, so that's why I kind of got a little lost there. So okay, now we're good. That's a good trajectory there. So yeah, we're looking at this. This should be mainly, especially where we're seeing a lot of the gas coming out. I'm assuming this is the February 8th flow. Might be a little bit tricky to differentiate the December and the February lavas just because they're so close in terms of time. And the December one's probably actively degassing as well. We can see some of the sulfuric precipitation on the lava flows just below us here. So let's see if we can get a little better view of that. Kind of tip the camera down, move forward a bit here, and then maybe also drop down. So you can see these patches mainly through the fractures, right? So you can see that yellowish color there through those fractures. That's where we're seeing some of the active mineralization. So as those volcanic gases, hydrogen sulfide and sulfur dioxide, are escaping from various parts of the flow in the vent, that actually, as it hits the atmosphere in the air, a lot of that causes precipitation and mineralization on the surface of the flow there. Let's see if we can get a little closer and go down a little bit maybe. So great view here. And you can just see how fractured that surface is, where the degassing is taking place. And here we're looking more or less, swing around. Now we're looking pretty much south towards Grindavik. We can't fly all the way down there. That's probably a little bit too far out of range. But just fantastic surface flows here. I mean, essentially you had, when we had these fish eruptions in the last 3 events, feeding these flows, even though they were moving outward, this area here was behaving a bit more like a lava lake at times, where the lava was just, pooling in little low areas. Might be looking at 2 different flows here. Right in front of us here, you can see a little color change, the more black, kind of glassy flows, and then just ahead, this flow is a little bit different color. So this could be older December lava, and then the fresher lava from the February 8th eruption. I'm going to zoom in here on some of these features. So we have zoom features, which work really great. And then, of course, when I hit the space bar, you guys probably can't tell, but are able to take photos that can then later be uploaded. So the detail is pretty good on the camera here. So you can see here, there's a really nice spot with that yellow mineralization. That's all the sulfur, sulfuric gases that have come out and then concentrated on the surface of the flow. And then you can see it's right along these fractures, and it's still actively degassing. So, and those are the really dangerous gases. Those are definitely the types of gases you don't want to be breathing in or be close to when there's an eruption going on. We'll swing around here to maybe to the east. Fly over. So this is, I mean, what's fantastic about this and just sends chills up my spine is just considering that this is the newest patch of rock on Earth, essentially. I mean, you're looking at rock here, crust that's not even a month old at this point. And this is the most likely area, of course, where we're expecting the next eruption. We know that the next eruption is likely to occur any time now, possibly, hours to days to maybe a week or so, but definitely in the near term. A couple more vents over here that are still degassing, so we can kind of take a look at these a little bit more closely. So there's another spot where we have some of the sulfuric gases. Maybe zoom in on this one a little bit as well. And maybe move the camera up a little bit and over to this way. Yeah, so you can just see how vibrantly yellow those areas are. Amazing. All right, let's see. What else can we go investigate? What I was hoping to find over here, and I just don't know exactly where it would be, but if you remember during that February 8th eruption, we did have, make sure I know where I'm at with respect to the hill. Okay. We did have a section of the vent that was mixing with some groundwater, had maybe collapsed, in talking to Professor Thordarson, and we had quite a bit of steam and ash coming out of that area. And I was hoping to be able to find that, but I think it's such a big, vast landscape that, and I didn't really have a good spatial reference for like where that area was. So that may not, I probably won't be able to find that. But my hypothesis was that area probably is widened quite a bit. That part of the vent, if we could find it and locate it, would probably be a lot wider due to the collapse, if that's what took place, and then also the emission of ash there as it was mixing a bit with some of the groundwater. So take a look at this one here. And zoom in just a little bit as well. And maybe move forward a little bit. Move the camera up. Yeah, so another place where it's actively degassing. You can see some more of the sulfuric precipitation, native sulfur. There's very few minerals. Most minerals on the planet, or excuse me, most elements don't occur in nature as minerals, but sulfur is one of them. It actually can be found in nature in pure form without being combined with other elements. So that those little yellow patches are native sulfur. And so here we have definitely the February flow here. Few little patches of ground that the lava went around. Those have a fun Hawaiian name. Those are called kipukas, Kipuka. So these little patches of mossy ground that are completely surrounded by the flows. I do remember this crater here. That's an older crater from the Sunukgiga crater row that's sticking up, and that was somewhat reactivated, I remember, during the December event. So just taking a look around, little 360 view here. Spin around a bit. Now we're looking east. Some more sulfuric deposition there in the foreground. And then now we're looking to the southeast and then to the south. And maybe we could go, let's go over here, check out this prominent, this might be the one actually I was thinking of, the existing crater. Yeah, this is actually the one I was thinking of. Oh no, that's the one we're going past. I was looking at the map there. This is probably a new crater. Probably February. So you can see we have here like a bit of a spatter cone, so a little bit bigger cone. And Johan, if you could go on mute a little bit, that would be good. Thank you. Right, so here's a much bigger little crater. This is where we would have the lava just being ejected from the vent, airborne, and then piling up around the vent to form this more steep-sided feature here. This is what we might call a spatter cone, or sometimes when you see a ridge of this parallel to the fissure, these are sometimes called spatter ramparts. So let's swing around here and kind of head back. I do want to go look towards the Blue Lagoon. We're not going to fly over it. So now we're looking more or less to the west. We go up a little bit here so we have good connection. And let's go check out this this long flow lobe that came out of the February 8th crater. Yeah, make sure you hit the like button on the YouTube channel. This is also being broadcast on NatureEye's various social platforms as well. So again, thanks to them for providing this opportunity. Pretty incredible technology we have now where we can do something like this, sit in my office in Idaho and fly a drone over possibly the newest patch of Earth on the planet in Iceland. Remember, you can use the promotional code. I have that under the video description, and that will get you a $10 discount off of your flight, whether it's in Iceland or one of their other locations. So make sure you check out their website and look at all the options that they have in terms of locations. Great gift idea, great way to experience nature. You can take your own photos. And we're kind of in a day and age where a lot of us we have enough stuff, right? We're all about experiences. Like, that's the way to really surprise someone. So now we'll head towards the west, and this is definitely all February 8th flows that came through here. So no December lava overlapping. And let's see how this flow looks. We'll get a little bit lower here. Drop down. And a lot of these lava flows will transition as they come out of the vent initially. They'll be very hot, very smooth type flows, what we call pahoehoe flows. But as they continue to move down slope, they'll start to cool. Um, they will develop sections of crust, and then the lava flow can end up sort of rolling over itself. And you can see we've got a very different sort of texture now. It's more broken up slabs of lava. This is what we call slabby pahoehoe. So this is a typical transitional form of lava from the very hot fluid pahoehoe flows. Usually it becomes this slabby pahoehoe flow. And then as it moves even further down slope and starts to roll over itself even more, you can get what's called lava, which is the slowest, most sluggish type of lava. Oops, I was pushing the wrong button there. I want to tip the camera up. There we go. And let's drop down a little bit. So a couple little vents still degassing here, just places where all the lava is. There's, the fractures in the pore space in this is interconnected enough that you can see where the gases are coming out of the lava. When our drone flight ends here in a little bit, because we're limited on about half an hour or so of battery power, make sure you stick with me and we'll do a little review of some of the latest data from Iceland and what we can expect moving forward. We'll fly this as long as we can, though, before signing off. So there's that western lobe, that tongue of lava that encroached upon the Blue Lagoon and Svartsengi power plant area. We'll go take a look at this over here in the roadway, and that'll get us probably close to our battery limit. And at some point here, we'll let Johan take over and fly this baby back to home. But you can see the road there. It looks like there's a bus moving down the road. As far as I know, the Blue Lagoon is open. And so there are people there. They do have evacuation plans put into place. But an eruption, even the Met Office has said that this next eruption could progress quite quickly with little warning, maybe just tens of minutes versus hours once the earthquakes start to occur, now that we've established pathways to the surface for that lava flow. So this was all molten less than maybe about 3 or so weeks ago on the 8th of February. Pretty incredible. So this was a tongue or a lobe of lava that flowed down. You can see there's a little bit of a depression there, a little low spot in the topography. And even though there were a few little, bulbs of this thing that kind of moved out to the sides, none of it really pushed on the protective berm, which you can see there to the left. So there's that protective wall around the power plant in the Blue Lagoon. There's the main roadway. So they've reestablished the roadway right over the top of the lava flow, just brought in some fill material there for that. And then we'll just maybe start swinging around here. And we're just about out of battery. So at some point here, Johan will be taking over, but we're pretty close to base. So yeah, it looks like he's got the controls now. So awesome. Yeah, Johan, if you you can unmute yourself and maybe you can talk for a second about just using the drone, if there's something you want to share.
Oh yeah, hello there, Shawn.
Yeah, thanks for joining us.
Yeah, that was a great flight. Thank you very much.
Yeah, thanks for.
Yeah, so we are expecting an eruption in hours, days, or weeks. Of course, we don't know, but the land rise has reached the same level as before the last eruption.
Right. Yeah.
As you said the other day, it's been like clockwork almost. It fills up and then empties.
Yeah. So I think Professor Thordarson called a good analogy was like the lid on a pot. Once the pot is kind of pressurized, then the lid rises and the magma comes out.
Yeah, that's exactly how it is. And these have all been small, of course. We are, of course, pretty scared of a big eruption that might happen. if these are just small spatters, and a big one might come.
Right.
But hopefully the town of Grindavik is safe for now. And but the next eruption could extend out to sea, and of course, Professor Haraldur Sigurðsson is talking about the possibility of the active area moving east to the Keilir area
Right.
and the Krýsuvík area, and so that would be good for everybody if it would move away from Reykjanes.
Yeah, that would be
But
great.
there's also the possibility of it moving west.
Yeah, lots of options. And I think, with each earthquake, each event, I think the plumbing system shifts and changes a little bit. And, so we should treat each one, with a little bit of a fresh perspective, in that there's a lot of unknowns. I'd hate for the people of Iceland to become so complacent that they think, well, it's going to be in the same place on the same schedule, because that's probably not always going to be the case. But excellent. Well, thank you, Johan, for being our assistant pilot today and being our guide. We're going to go ahead and sign off with NatureEye, but appreciate all your help here today, my friend.
Thank you, and I'm looking forward to our next one.
Okay, thanks so much. All right, thanks, NatureEye. Take care. And there's our last images of the lava field there. All of this could be drastically changed in the next hours to days. So thanks, NatureEye. Okay, so what we'll do now, friends, I hope that you found that helpful. Hope that was fun for everyone. I sure had a blast doing that. What we'll do now is we'll switch over to looking at some of the monitoring data. Again, this live stream might be a little bit shorter than it has in the past. I've got a class here in a little over an hour, so we may not be able to get to all the questions that we normally do, but we'll do what we can. So let's look at the monitoring data from the last 24 hours. This, of course, is the earthquakes. The only real interesting thing I think that happened in the last 24 hours was there was a small cluster. I wouldn't call it a swarm, but maybe a dozen or so quakes between Hagafelt, this hill right here, and Grindavik. And so, but these occurred at about, if you look at the time here, like 3:00, 3:45 in the morning, Iceland time. This one about the same. So at that moment, had I been watching it at that hour, it might have been a little bit concerning. But now that we're, a good, almost 12 hours or so beyond that, I don't think it portends that the eruption's likely to be here. What we're probably seeing is that the entire dike, or some of the magma dike, is starting to accumulate with magma and start to fill. And then once any given section of it reaches, that critical pressure and fractures and splits, and that magma starts migrating towards the surface, that will be where the eruption and vent is. But right now it's probably pressurizing along its length to some degree. And it'll just be a question of exactly where the weak spot is in that magma intrusion. Will it be down here by Grindavik, which we hope isn't the case? The most predictions are right in here, the place we just flew over between Stora Stogafelt and Sidingarfelt. Could it be further to the north? Possibly, but somewhere along that zone is the most likely place for that next eruption to take place. But really, not a lot of earthquakes. If I switch this over to the last, let's say, last 6 hours, there's exactly one earthquake along that trend, and quite deep, 5 kilometers or so. So you can see that it's pretty quiet recently when it comes to earthquakes. And so, but that's somewhat to be expected. The plumbing system's been established. So although we will see some seismic activity immediately preceding the eruption by a few tens of minutes, we're likely to not see a lot of earthquake activity, and definitely not a lot of higher magnitude earthquakes, strong earthquakes, because we've already broken this rock. The magma system, plumbing system has been well established. And so those are some of the things we might look for moving forward. But certainly if you see another cluster like that occur in short order, that could possibly be a sign that that's the location where the eruption may occur. If we look at the Met Office data in terms of earthquakes that have happened over the last 24 hours, just kind of plotting them up by magnitude and time. You can see there was, quite a few yesterday or Monday, excuse me, late in the day Monday. Tuesday was kind of quiet. I also know from Amanda Joe that the weather was not awesome, so that may have been hampering some of that a little bit as well. And then you can see today's earthquakes on Wednesday, just a little bit of a pickup in terms of earthquake activity. But again, nothing huge there, nothing, I think that would be, hugely indicative of an eruption happening anytime now. So there's our earthquake data. I do want to go to the Met Office had an update yesterday. So this is yesterday's update, very similar to the one I shared with you last time. But the main thing is that they updated this graphic here to show um, the most recent uh, calculations and estimates on the magma volume. So remember, this graphic here shows the last several either eruptions or intrusions in the case of November 10th, how many days, that led up to that event, and it's anywhere from, 28 or so days at the high end to as few as about 13 or 14 or 15 days. We're well past 15 days since the last eruptive event. And so where does this red line, which is our latest progression, where does this end up coming to an end? When does this red line terminate because there's an eruption? Will it be on day 20, day 22? Well, we're definitely in the zone. So we're definitely within the window of time that is expected. The other thing the Met Office had out that I thought was pretty interesting that I have not shared before is we did talk about further up in this update, they mentioned different scenarios, and I went over those with you last time. Basically, one scenario is something similar to what took place this last time in February and in December in terms of location and in terms of warning time and magma output. And then another possible scenario was what happened on January 14th, where we had the vents opening up much closer to Grindavik, the town. That one had a little bit more warning time in terms of earthquake activity, but that also meant that the lava reached the town a lot quicker. So these maps here are scenarios that they've run, modeling scenarios of a possible eruption. So with this scenario here, scenario A, the black line represents the fissure. So if a fissure opened up here, so hypothetically, if this was the location, and they're assuming that the flow of magma was about 600 cubic meters per second, and it lasted for 6 hours. Basically, this model simulates an eruption site, an eruption discharge, volume per time, and then a duration, 6 hours. And then with the purple, what it's showing is the extent of the lava field, with the darkest shade of purple being the most likely probability that that's where the lava goes, and then the lighter shades of purple being less likely. And so you can see an eruption in this location would mainly send, looks a lot like the February one because they picked more or less a similarly located fissure, similar volume outputs and times. So you can see it largely parallels that flow path, little flow headed to the north around Stora Stogafelt, and then a bigger branch of lava coming out here to the west. Looks like they have it lapping up against the berm with this nice sharp line here, and possibly impacting a little bit of the Blue Lagoon parking lot. And then one little less likely scenario actually even shows, if you kind of zoom in here, let me get this centered for you, even shows some of the lava, possibly low probability, breaching the barrier and a little tongue coming into the Blue Lagoon area. Again, this is just all modeled, hypothetical type of information, but pretty interesting. And then they have here a little bit of that lava also moving off to the east, and then starting to cover some of these other flow areas that we just flew over with the drone. So that's scenario one scenario with a vent opening up in this region, and then lava flows mainly being a threat to the power plant Blue Lagoon area, along with the roadways and the pipeline. And then the other simulation is an eruption further south. In this case, they moved the vent to the west side of Hagafeld, which I found interesting because we had them open up. I think they were on this side last time. Yeah, so on January 14th, we had vents on the southeast side of this hill, but in this simulation, they've put the vents here. And then let's maybe look at this broad details, and then we'll zoom in a little bit. So they do have possibly a little tongue of lava. Again, same volume or output of lava and same duration. So a little bit of that lava wrapping around the north and then the east sides of Hagafeld, and then forming a kind of a narrow tongue, probably following a little depression in the topography, and possibly low probability, but possibly that maybe even making it out to the coastline, which would be interesting. And then the bulk of the lava they have actually flowing between Thorbjorn and Hagafeld, completely covering the road and the pipeline area here, running up against the protective berms. In some cases, they have the lava actually overtopping the berms, and then you can see the main area of impact to Grindavik is on this west and northwest side of town. So if we zoom in a little bit here, and maybe zoom out just a skosh, we can see the projected impact here. Again, this is just a scenario, it's modeled, but it's a good thing to do. It's a good way for scientists to make estimates of impacts and how much lava would, how much area would be covered by lava. So you can see there could be damage to some of these homes. Few places here where maybe the lava breaches the barriers, which I know they're trying to heighten and make taller all the time. In gray here, you can see the January 14th event that we saw erupt that took out 3 homes, and then the main January 14th flow field. There's the greenhouse there. And then looking up a little bit at where they have this vent opening and then the projected flow paths. So pretty interesting stuff, but great work by the Met Office. I think that's a great visual representation. And this is how we do hazard analysis. We take what we know about the area in terms of its hazard. In this case, we're using the last 3 eruptive events in terms of their locations, in terms of their output and duration. And we're just projecting how that might look in a future scenario with different locations for the vent and what the flow paths might be. So then that helps public officials maybe manage a future event to some degree. Very cool. So I found that to be really a great visual and just great work by them. So if we look at the GPS data, which I haven't done a whole lot of today, so this will be sort of a real-time look. If we look at the Svartsengi data, we can see uplift occurring at this station near the power plant, the December 18th eruption, January 14th eruptions in here, February 8th, and then since the February 8th eruption, we've had steady uplift, but it's been, it's overall trend has been upwards, but there's been little lulls here and there. And then the last few, it looks like it was slowing down a bit here. Maybe we'll zoom in just on that a bit. Take a good look at those little red dots. So there was actually a little downward trend maybe a few days ago. Then it resumed, but it kind of stagnated a bit. But the last 3 points, a little bit steeper. Recognize that all these red dots have error bars on them. So you can't take the red dots location as completely absolute, but definitely an overall upward trend. A little bit of a lull, then kind of steady increase. There was a little downward trend here, and then 3 dots ticking upwards. Who knows if that's something that will persist or not. I would guess the next couple might bring that back down a little bit and continue this more long-term trend. But there's the Svartsengi site. Another one we often look at is the Blue Lagoon, which shows a similar trend. This one nicely shows the 3 eruptive events, December 18th, January 14th, February 8th. You can see that lull right here, and then it's picked up a little bit, which is interesting because in the last one, this one definitely did taper off. Once the system was very pressurized, the land couldn't uplift anymore, and so the data stagnated. The pressure built up, and then we had that February 8th eruptive event. We didn't see that exact pattern play out with the previous two eruptions. And so what will happen next here as we go into the last days of February is anyone's guess. But it'll be interesting to see, once we get, months from now, if we have a bunch of these inflation deflation cycles, I think then it'll be a better time to assess all these trends long term and see if there's any consistency. But right now we have just limited sample size in the data, which is can be misleading, and you don't want to make any rash conclusions from that. And then maybe the Eldorp station, which is off to the west, again, December 18th, January 14th, February 8th. So steep inflation, and there you can see that lull, that sort of, it did slow down a little bit, but then it has picked back up recently. But then there's a little down drop here. Again, just 3 dots is not alarming, and bigger error bars here. So who knows, but interesting kind of comparison could be made there. But you can definitely see on this one just as well the lull in activity in elevation inflation, I suppose, or elevation rise the few days leading into the February 8th eruption. So GPS data continues to show us the same trends we've been watching. And then finally, the last thing I have for you here is a news article, and then we can come to you for questions, and I can probably hang with you guys for a good 30, 40 minutes or so until I need to run off and give my other customers, my students, some attention of class at that time. So this was an article with has some quotes from Professor Thordarson, who I interviewed last week. He says here, there's a nice quote from him here, that the magma is getting to the limit. And he said the other day, speaking of Professor Thordarson, that the eruption will come on March 1st, and he's thinking of sticking to it. Interestingly, my last live stream, when asked by a viewer if if I was a betting person, what day would I pick? And I picked March 1st. I had no idea he had picked the same date. But 2 geologists agreeing on a date, I don't know if that's really something you should rely on. He seems a little more, he's sticking to March 1st. I just threw it out there. Felt like a nice, fun number. I obviously have no idea, neither does he, when this thing's going to erupt. But I do think we're just now getting into the minimum volume of magma needed to trigger an eruption. So I really didn't think it was going to happen today during the live stream with the drone, although that would have been a fantastically wonderful experience. I still think it's going to be at the latter part of this week, maybe into the weekend. If it was next week, Monday, Tuesday, and it hadn't erupted, I guess I'd be a little bit surprised. So the next couple days, I think, is the most likely, but no one knows for sure. But he does the little lid analogy, which I really think is a good way to describe it. He talks about that the most likely location is the one we're all agreeing upon between Stora Stogafelt and Hagafelt. What else is here? Yeah, that the greatest probability is in this same region. We can't rule out another vent opening up to the north or south, but it's most likely to be there. So, and then he talks about kind of long term, that this could go on for months, possibly years, with this sort of pattern. It's just kind of a wait and see and kind of figure out what the long term trends are. So, okay, so I think if Amanda Joe wants to send me, if there's been any questions that have come up, that would be great. A couple things that were new for me today with this live stream. So when we do live streams with NatureEye, that means that, oh, I need to switch this over to this view. When we do things with NatureEye, it's a little bit different setup on my end, and so it should look the same to you. But if I'm seeming a little bit confused or more awkward than normal, sometimes that's what's happening. They use a little bit different streaming platform than I'm used to, but I am getting more used to it. It's called Restream. I like to use the OBS Studio in conjunction with that. So let me switch over to the Google Earth view here, and Here we go. Okay. And then I can look for the questions from Amanda Jo when she sends those through my email. So, but until she sends those, I can probably scroll through the chat. Maybe I can just start on some questions since we're a little tight on time this morning with my teaching schedule. Yeah, and scheduling these is always tricky because, it needs to be daytime to operate the drone. I'm 7 hours behind Iceland. I teach classes in the morning. And so sometimes threading the needle for the time that works for everyone is a little bit tricky. And we did kind of scramble and get this put together a little bit late in the game. And so I apologize for the late notice. If you're just kind of getting on here and you didn't know this was happening, my apologies. It was sort of I wouldn't say last minute, but it was a very late thing that we threw together. And depending on what time zone and such you're in, that could affect things a little bit. Okay, so I got the questions from Amanda Jo, and I need to, it makes me switch the screen share each time for some reason. Okay, so let's go to the questions. Let me make those a little bigger for you. Okay, so we'll run through, and again, there may be more questions than I can answer here this morning, but I will get through as many as I can before I need to end the live stream and hustle off to my Geology 101 class. From Jessica Sunny, is there still some fluidity underneath all the black, or is it all solid now? There is probably still there's undoubtedly still incandescent lava beneath the black. So if you were lucky enough to see a fracture through the surface of that black lava flow and see deep enough into it, you would see orange glowing magma. So in terms of its fluidity, that implies that it's able to flow more. It's probably lost most of its ability to flow because it's slowly cooling and crystallizing. So it's becoming very viscous and thick and pasty. So fluidity, I'd say no, but in terms of incandescent and glowing, what we think of when we think of lava, yes, underneath it still retains that. Rock is a pretty good insulator, so it is able to insulate a lot of the heat and keep that lava hot for quite a while. From Kelly Hills, you mentioned that the February 8th lava was glassy compared to the December field. Is this because the December field is older or slightly different lava composition? Yeah, that was just sort of a quick gut judgment call when we were flying the drone. I had no idea what I was looking at. If you told me that I had it the opposite and the slightly glacier flow was the older one, that wouldn't be too surprising. Essentially, they're the same age for all intents and purposes. But typically what happens with lava when it's first erupted and fresh is it will be kind of black and glassy-ish. It can be iridescent and show some play of colors when the sunlight hits it. And then over time, as it reacts with water in the atmosphere and rain and stuff, as it starts to, the iron in that lava starts to oxidize. And so it starts to take on more of a blackish color or even kind of a deep reddish hue. Yeah, and they do get, I mean, in Iceland, there's so much weathering and rain and moisture in the air that those flows can weather a lot more quickly than if it was here in southern Idaho, where it's a very dry climate. So we have lava flows here in Idaho that are 2,000 years old, and some of them still have the iridescent surface on them, which is pretty remarkable that after 2,000 years, they still look pretty fresh and glassy. And then you can go to a place like Iceland or Hawaii, look at flows that are only a few tens of years old, and they can look a lot older than even those here in a very dry climate. From Turner Rents, can I comment on Professor Thordarson's assertion that the Reykjanes Peninsula may be fraught with possible upward magma path? If I'm reading that question correctly, I mentioned in my interview with him that there's this narrative that the Reykjanes Peninsula has woken up and entered a new phase of unrest. And I think that's true. I mean, there has not been any eruptions on the Reykjanes Peninsula for 800 years. And now we have 6, and we're waiting for the 7th eruption within a few days. And all of those eruptions have taken place in the last 3 or 4 years. And so, in terms of it being fraught with possible upward magma path, I don't think we're necessarily looking at multiple volcanic systems erupting simultaneously. Right now, we're kind of focused on this Svartsengi area. We're still looking a little bit to the east at the Fagradalsfjall area because that had eruptions, 3 eruptions over the past 3 or 4 years. So these 2 zones seem to be the most likely areas now. Is it possible another volcanic system, if we want to use that term, becomes active in the Reykjanes area? Sure. But I don't think it's, yeah, we just don't know exactly. What we can say is that in the past, we've seen them all erupt during a similar window, not at the same time per se, but when one's active, they tend to all kind of be active. So it could be that this batch of magma that's being fed into this area at depth is right now feeding this system, but could potentially start feeding adjacent systems as well. So hopefully I kind of gave you a satisfying answer there. From Camilla, what would be the differences between gases when lava is cooling down after an eruption, vents, and the gases in the beginning of an eruption? Have been watching vent above the greenhouse. It's similar. During the eruption, you have probably more gases coming out. Because you have an active and open vent, so you're emitting higher concentrations of volcanic gases from a vent that's erupting. Once the eruption is over and we just have lava covering a landscape, you're only degassing the lava that's there. So the lava still has trapped gases in it. Those gases escape, and that's what's rising out of those lava fields that we just flew over. And so in terms of composition, there's really no difference in the composition. In terms of concentration or volume, there's a big difference. The lava field is degassing, but it's mainly degassing in highly permeable fracture zones, but it doesn't have as much gas in it, and it will degas completely after some period of time, versus an active vent still is connected to the subsurface, and so it has a constantly renewed supply of volcanic gases. From Keith Dowsett, if a lava field is covered by a further eruption, does it still degas through the newer lava? Yeah, that's an interesting thought. So we've got December 18th lavas, and in some places we covered those with February 8th lavas, and the December lavas were still degassing. They were still pretty fresh, covered by another one. And so it makes sense to me that, yeah, you'd still have that older flow degassing. And as long as the fractures are there, as long as that gas can rise through the material, whether through the fractures or the gas bubbles or any pore space, then it would continue to degas. Where is most uplift currently, says Cindy? I think most of the uplift is, if we look at the INSAR data, there's the hill just south of the power plant and north of the town called Thorbjorn. And the uplift is just to the west of that hill, the central part of the uplift. So it's not directly perfectly centered on the power plant area. It's a little bit southwest, maybe a kilometer or so, maybe 2 southwest of the power plant. From Nancy, why was there such deep fissures in town, but no magma and now frequent quakes? So the fissures, the cracks that opened up in town were related to, well, a couple things. So we had the November 10th magma intrusion, and as magma forms a dike, what you typically get above the dike are fractures and subsidence right below the center of the dike, because as the rocks are being pushed away, that creates a graben, that creates a little downdrop block bounded by normal faults. And so a lot of those big fissures in town are there because of that. So as the magma was pushing its way, not just towards the surface, but also to the south towards town, that was opening up these fractures. There was not magma there because the magma just didn't have quite enough volume or pressure to propagate all the way, to propagate not just under the town, but then upwards as well. And then also the magma found an easier pathway to the surface to the north at the eruption sites we saw over the last 3 eruptions. From Joe Carter, are all the hotspots the same age? No, they're different ages. I think the Iceland one goes back 60 million years for sure, and maybe a little bit older than that, at least we have record of. The Yellowstone hotspot We used to think the Yellowstone hotspot initiated about 17 million years ago, but now there's really good evidence from off the coast of Oregon that it initiated out there and is something like 50 or so. I'll have to check my numbers, but it's much older, 50-ish million years. And then the Hawaiian hotspot, which you can trace from the Hawaiian Islands out into the Pacific and all the way up to a subduction zone off the coast of where, like Russia, the Kamchatka area. That one, oh shoot, how old is that one? It's like 100. No, it's like 80 million years old, something like that. It's pretty old as well. So they're not all the same ages. They seem to have different ages. But with some hotspots, we don't have a clear any clear evidence that lets us know exactly when they started. So the age we have is a minimum age. Could the hotspot be older than what we think it is? Yes, we just know it goes back at least to this point. From Larry, since the last eruption followed low zones in topography and filled those in, would a similar eruption be more likely to reach new areas such as the berm? Yeah, once that lava's on the ground, it's following the topography, it's following the low areas. And that's why the modeling that the Met Office did is so important, is they're able to take their aerial photography or their topographic information, so they know what the land surface is like, that older lava surface where the hills are kind of punctuated in there. And then they can say, well, what if we have an eruption here and here's this much lava over this much time, and see exactly where that's going to go. And then, of course, we're creating some artificial topography by erecting these berms and these barriers to the lava flow. And those change things a little bit, but you can put those in your model as well and see how the lava might respond in that case as well. Did I answer your question? I hope I did. Yeah, so a similar eruption. And then what's interesting is after every eruption, you add lava, and so you fill in some topography, and now the topography is a little bit different because what was low is now a little bit higher. Lava flows could go into a low valley, and then they can inflate, sometimes 10 meters. And so it's worthwhile after each eruption, if you're going to keep doing this type of modeling, to get new, accurate topographic data, whether that's from satellites or aerial means or however you get that, and then put that into the computer and simulate another event with that new topography. That's an important thing to keep doing moving forward. Northern last, is there a possibility both the northern end of the fissures and the southern end both erupt in one event? Possibly, but that would require a very pressurized, higher volume magma system than what we've seen in the past. So I'm assuming when you say the northern end of the fissures, you mean like the December 18th eruptive event and maybe even further north of that. And by southern end, I'm assuming you mean in town or even offshore, like the entire 15-kilometer length of this magma dike. That would require, we'd somehow need to keep the system pressurized longer in order to build up the pressure and volume needed for something like that to happen. And right now, it just seems like the pathways exist for that magma to escape at a lower volume and with less pressure. But it's possible. Every time there's earthquakes, every time there's an eruption, like I said, we're changing the system to some degree. So it's not always the same for each eruption. If there was a big earthquake somewhere, that might shift things a little bit. There's all sorts of little variables that could change this thing in terms of location and behavior. Cindy again, what are the odds of multiple locations of eruptions opening at the same time? Yeah, similar question. I think I addressed that there. So hopefully that makes sense there. Great. And I think we've got time, maybe Amanda Jo, maybe another, I don't know, 8 to 10 questions. I think I went through those pretty quickly. So hopefully that was satisfying. How's everything doing on the live chat? I'm just taking a look at that now. So yeah, so if you have a couple other questions, I have some time to answer those. I have no idea how many people are on here. It's always interesting doing these from my perspective because were it not for the live chat, you would say there's an insane person in that office because they're just sitting there talking to their screen. So it looks like, let's see, let me check a couple things here. The NatureEye folks were really happy with things, so that's good news. And if Amanda Jo can just send me another batch of questions when she gets a chance, then we can move on to another set of questions. I suppose I can check. Let's check the webcams real quick. Let's go to a different screen share. And let's see, which one do I want to do here? Is it this one? Yeah, we can check the webcam real quick. Yeah, so, if you're kind of on pins and needles about this thing and ready to watch it go, I think the first signs very likely will be some viewers watching the webcams. So Live from Iceland has some nice webcams on YouTube. This one is a favorite because it has 4 views kind of at once. So this is looking from the town, looking more or less due north. There's Hagafelt there. There's Thorbjorn there. This view here in the top right is showing the berm around the power plant. So this is from the top of Thorbjorn looking northwest, I suppose. There's the steam coming from the power plant. So I would guess this camera isn't going to show an eruption. I don't think there'd be a vent opening up anywhere here. But that's that camera. And then this one is looking from Thorbjorn, from the hill just north of Grindavik, to the east or southeast. So there's the edges of Grindavik there. There's the greenhouse. There's the flows from January 14th. You can kind of make out the berm there. And so there could be an eruption and lava that comes through this view and possibly this one as well. And they have other cameras as well, but those give you a couple of ideas there. So, okay, round 2 of questions, and this will be our last round. So let me switch the view. I got to figure out this restream thing because it's a little wonkier. Let's see, where is... Oh, maybe what I need to do first is grab the questions. Close that one down. Sorry here, team. Just bear with me for a second. Open those questions up. And all right, here we go. All right, round 2 of questions. And this will be the last one. I'll need to, probably when we get through these, I'll need to head to class, go get ready for class. Let me grab a quick drink of water. Susan Weimer asks, as the rock under Svartsengi inflates and deflates, is it likely that the cap breaks elastically and then an eruption could happen under the power plant? Great question, and one that's been posed not by other folks, but even myself. So, what's the magma? The magma is not even... Most of us can think about volcanoes as having a magma chamber, and then the vent is directly above the magma chamber. But this volcanic system is showing us that that is not always true. Our magma chamber is located to the west under the power plant region, and that magma chamber is feeding, or reservoir is feeding, magma through some sort of conduit system to the east, where it then intersects fractures or faults that are oriented vertically, and then it propagates to the surface and forms a vent over there. It would make sense to a lot of people, and this is what Susan's question is like, well, every time it goes up and down, aren't you weakening that rock such that it's possible that an eruption, a future eruption, one of these eruptions is going to be directly near the power plant, right above the magma body? And it might not happen that way. It could be, and Professor Thordarson and I talked about this, that there's something about the Svartsengi area. The rocks there are very strong. They're robust. They seem to lack the permeability and the degree of fracturing that allows the magma and heat to rise to the surface. We even talked about the Svartsengi area is a power plant, right? They're tapping geothermal energy. They're tapping hot groundwater, and that's at like maybe 2 kilometers depth. At 5 kilometers depth is the magma body, and yet something about the rocks in between those two areas doesn't even allow the heat to impact the groundwater supply. So literally underneath the power plant is where the magma is. We all know that, but it's not even affecting the hot water, the groundwater that's coming up through their wells, and that goes into the Blue Lagoon there. So there's something about the rocks there that are more robust. They're able to behave elastically and bend a little bit and allow the crust to move up and down, but they don't actually break. They don't have as much fracturing. They're not as weak as the rocks to the east, which for whatever reason have formed a much easier pathway for the magma to move. Um, so is it likely that it breaks? So far, it's not showing any signs of doing that. So we continue to assume that the magma is going to find the pathways that it has. Now, could there be an earthquake or some other event that changes that dynamic? Sure, but until then, we'd expect more of the same. From Pebble, could there be an eruption both at the north and south locations? Yeah, I think I answered that with the last batch of questions. So great question there. From Ann Umphrey, any ideas on where the hotspot under Iceland? Well, the hotspot's a zone, it's an area. And Professor Thordarson brought up a really good thought that I had not really considered, and that is no one has actually been able to discern or estimate or determine the extent, the aerial extent of the hotspot. Is it a narrow zone that's maybe 10 kilometers across in terms of map view? Is it 30 kilometers? How big is it? But what we do know is that the hotspot has a role to play in nearly all the volcanoes in Iceland. Its center, the center of the hotspot, is further to the east underneath the big ice cap in Iceland. So if you look at Google Earth and look at Iceland, the biggest ice cap you see, Vatnajökull, is the west end of that is actually where the hotspot's center is. But the hotspot seems to be also feeding other systems, including this one here in Reykjanes. So this area that we're focused on has magma supplied to it from both the hotspot and also because it's part of the divergent boundary that runs through the Atlantic Ocean. What we don't know is how much of each contributes to the overall magma supply. Is it 50-50? Is it 70% hotspot, 30% divergent boundary? Those are all things that have not been figured out as of yet. From JM Fitz, could a lateral sill push lava from Svartsengi to the 2021 eruption area and lava come up there? Maybe. I mean, anything's kind of on the table. But right now, why would the magma bodies near the power plant, why would it bypass these fractures and vents that it's already established, in this Sunukur crater area north of Grindavik? Why would it bypass those and feed another system that's kilometers to the east? The other area, the Fagradalsfjall area to the east, probably has its own conduit system and plumbing system. And could those two plumbing systems either now or in the future possibly intersect and be shared? Sure. But right now they seem to be, even though the magma supply at depth is common to them both because the chemistries are the same, right now they have their own separate plumbing systems and vents. And so for now, I think that we would not see that. From Christina Johnson, why aren't these eruptions creating cones that can be new mountains? It's mainly a consequence of a couple of things. One is that the weakest zones that the magma moves through are these northeast, southwest trending fractures and faults, the fissures, right? So the tectonics of the area dictates that that's where the stress is weakest, right? That's the easiest path for the magma to move through, and that's why we get these long linear fissure eruptions. Also, the magma that erupts in this location is fairly low viscosity. It's fairly runny and fluid, so it doesn't really pile up. When you think about like a mountain, like a cone-shaped mountain, like a Mount Rainier or Mount Fuji, that's a totally different magma composition. It's much stickier and thick and pasty, and it erupts explosively sometimes, so it can pile up and make very steep slopes. Um, so and you could argue that these eruptions are making cones. They're just really small. We flew over one an hour ago. There was a cute little spatter cone along the fissures. So it starts out with this long linear set of fissures, but then over time, as the eruption progresses, it tends to concentrate the eruptive material into certain little zones along that fissure, and that does make small cones, like little spatter cones. But they'll never be tall enough to be what you'd call a new mountain, because the viscosity is so low, and our eruptions only lasted a couple days, right? So had one of these things really erupted for weeks, months, maybe even a year, could you get one of these turning into like a big, broad shield volcano? Sure, but until we see more prolonged eruptions or increased volume, that's probably not going to happen. We're going to continue to get these fissures. No longer listless. Hi, is there a reason why the Mid-Atlantic Ridge, that's what that stands for, is making the Reykjanes Peninsula, and before that, the Snæfellsnes westwards, but less active? Oh boy, I got to understand this. The reason why they're making the Reykjanes Peninsula westwards, but seems less active as the Mid-Atlantic Ridge leaves northwards. I think what they're asking, I'm not sure what they're asking. It seems less active. So if you're talking about where the north part of Iceland is more north trending, and then you pick up the ridge off the north coast of Iceland, and it's just as active volcanically there. They had eruptions there in the 70s, I think. It's just they're not active right now. I'm sorry, I don't totally understand the question. And I know you're limited on character spaces on the live chat, so that might be part of that there. Susanna, why do they have a lava flow scenario at Hagafelt where a fissure is more west than the one that affected houses? Why not the same place? Not sure. I'm not sure why they selected the fissures where they did. Yeah, why didn't they pick the same little fissure that we saw pop open on January 14th that took out the homes? Maybe because maybe because when they ran that scenario, the lava just covered the entire town, and that was a little too somber of a result. I have no idea. And undoubtedly, I mean, I firmly believe they probably ran way more than two scenarios. It's just that they chose to publish and post on their webpage two scenarios that just show probably the most likely scenarios, I guess. Good question. You'd have to ask them. I'm not sure. And then finally, our last question from Kathleen McCann. What is the elemental composition of magma? You mentioned sulfur and iron. What would a piece of chart of composition look like? What would a piece of chart of composition look like? So magma contains iron and sulfur. And sulfur is mainly in gas form, but it also contains, the main thing that magma contains is silicon and oxygen, which combined together is a compound called silica, which is hugely important when we talk about magma systems. High silica, low silica. Maybe you've heard the terms mafic, felsic. That basically refers to how much silica is in the magma, and the amount of silica in the magma affects the behavior of the magma. High silica magmas tend to be lower in temperature, higher in viscosity, which means they're thicker and stickier. They tend to trap more gases, therefore they erupt more explosively. So your most explosively erupting volcanoes tend to have high silica magmas. Low silica magmas, like we see here in Iceland in this case, are higher temperature, lower viscosity, meaning they're more fluid. The gases escape through them pretty easily, and so they tend to be a lot less explosive. Other things, calcium, potassium, sodium, aluminum, that's probably the main ones there. I'm probably forgetting a couple. Manganese, Those are some of the elements. You can probably look that up. You can probably just Google like magma, chemistry of magma, and probably find some cool stuff on that. So, okay, let's see where we're at in terms of time and such. Yeah, I probably need to shut this down soon, get it all buttoned up and posted, and then switch gears so that I can go teach my Geology 101 class. I've got 16 or so eager students. They're going to be super happy to see me. We're going to learn about sedimentary rocks today. So that'll be fun. So thanks all who've been on here. I did not give a proper shout out as I normally do to our great moderators. I believe we had all three of them here today. We had Susan Helmer, Amanda Joe, who goes by Mandy Joe on the live chat. And I think Lisa R. Lisa was there as well. So thanks to them for the moderation on the live chat. These run a little differently when we work with NatureEye. It's a little different platform for me. We don't do the little shout outs at the beginning. NatureEye likes us to just start the live stream and the drone is lifting off the pad because they're also broadcasting this to their platforms as well. And so I want to make sure that we're doing right by them and doing what they would like us to do. So hopefully this was helpful. I'll look at it later and see what I think. I'll read through all the notes there. Whatever you can do to support the channel is always helpful. There are links under the video description, how you might do that. If you want to reach out and provide some support to Amanda Joe as she goes through this difficult transition of selling and evacuating her house in Grindavik and getting her new home. There's a link there if you want to help her out there. Looking forward, programming wise, today's the 28th. Obviously, if there is an eruption, I'll try to get with you as soon as I can. Please realize though that there's days where, like tomorrow, Thursday, I have like labs from more or less 8 to 1 during the day. So if an eruption begins and I'm radio silent for a few hours, it's either the middle of the night or it's during a day where I've got a lot of commitments here at the college. But as soon as I can, I'll jump on with you, break it down. If we can get with NatureEye and put together some sort of a drone flight, that's obviously huge and that would be high on my list. Want to mention one last time that you can go also to the video description and look for my code Shawn Fly. And if you go to NatureEye and put in that code, that'll get you $10 off your flight. And they have lots of different destinations. So not only can you fly a drone over Iceland, take pictures, but they have places in Africa, Machu Picchu. I think there's one in Washington, Victoria Falls, which is in Africa. So it's not just Iceland that they have this technology and opportunities available. There's other places as well. So want to give them that proper shout out. Thanks again to our moderators. Thanks everyone for joining me today on this little special edition of the Lava Flight. Who knows? This might have been the last view of that landscape if there's an eruption really soon. That did happen back in December. We did a flight in mid-December on the 17th, and literally the next day there was an eruption. So you never know, but we are at a period where everything's kind of primed and ready to go. So thanks everyone for joining us here, and we'll see you next time. Take care, be well, and appreciate all you do to help our geology learning community. Thank you.